That's the real sound of Jupiter. Now, before you guys go absolutely wild on me telling me that, hey Rob, that's not possible. Space is a vacuum, and sound cannot travel. Thus, we cannot capture the sound of Jupiter. I absolutely 100% agree with you. But the sound that you heard in the video is not an ordinary sound wave traveling through space. Instead, it's a translation of electromagnetic signals. Jupiter produces extremely powerful radio emissions that spacecraft can detect. NASA's Juno spacecraft picked up these radio waves and plasma oscillations in the planet's magnetosphere, and scientists then converted those signals into frequencies our ears can hear. You see, whenever we talk about what controls our solar system, we always point to the sun. And sure, the sun has its fair share of light and heat. But when it comes to the actual structure of our entire solar system neighborhood, the sun might not be doing all the heavy lifting after all. There is something else that's also influencing the solar system, and scientists actually call it a failed star. And as you might have guessed, it's the biggest planet in our solar system, and the name is Jupiter. But the real question is, how exactly is Jupiter secretly controlling Earth's fate? Well, to understand just how much power Jupiter has, you have to look at its enormous size. If you took every single planet, every moon, every asteroid, and every comet in our entire solar system, mashed them all into one giant ball and put it next to Jupiter, Jupiter would still be 2.5 times heavier. Well, to say in simple words, it's basically a gigantic monster of gas and gravity. And because it is so massive, its gravitational pull somewhat influences the rules of the entire solar system. For a long time, we thought of Jupiter as just a giant, stormy gas ball sitting way out in the cold. But modern science, however, gave a very different picture. Jupiter is not just sitting there, but actively managing the solar system. In fact, scientists now believe that Jupiter played a major role in shaping exactly how our planet Earth formed in the first place. If Jupiter wasn't exactly where it is, doing exactly what it does, the Earth might have looked completely different. Or I might not be able to make this video and talk about it at all. To really see Jupiter's power in action, we have to look back at July 1994. This was the moment humanity watched a planetary defense system working in real time. Astronomers had their telescopes locked onto a massive comet called Comet Shoemaker-Levy 9. It was hurtling through space at a whopping speed of 134,000 miles per hour, and on its way, it got way too close to Jupiter. Now, what happened next is absolutely mind-boggling. The sheer tidal force of Jupiter's gravity was so intense that it literally ripped the whole comet into 21 separate pieces, and then swallowing it completely until there was nothing left. The explosions were so incredibly huge that they left dark, bruised scars in Jupiter's clouds. Some of those single impact scars were actually larger than the entire Earth itself. If just one of those fragments had hit our planet, it would have been an extinction-level event. And if you didn't know, the dinosaurs were wiped out by a rock much smaller than the total mass of Shoemaker-Levy 9. So yeah, you can imagine the impact and level of destruction this would cause. But here's where things get interesting. You see, after watching this happen, the scientific community came to a solid conclusion. They started calling Jupiter the cosmic vacuum cleaner. The idea was simple and reassuring. Jupiter is so massive that its gravity sucks up dangerous comets and rogue asteroids, taking the hits so that Earth doesn't have to. We thought we had a bodyguard, but as our computer models got smarter, scientists realized that this bodyguard has a very dark side. I try my best to provide you with real, authentic information, so if you're enjoying this video, consider subscribing and turning on the bell so you don't miss the next space discovery. Here is where the story of our solar system gets a little more terrifying. You see, Recent simulations run by researchers at NASA, the Jet Propulsion Lab, and major universities completely flipped the vacuum cleaner theory on its head. Yes, Jupiter definitely takes a lot of hits for us, but it doesn't just absorb comets. Because its gravity is so powerful, it also acts like a giant space slingshot. When icy comets drift in from the very outer, freezing edges of the solar system, a place called the Oort cloud, they don't always crash into Jupiter. Instead, Jupiter's gravity catches them, swings them around, and massively alters their path. Sometimes, it harmlessly kicks them entirely out of the solar system, but other times, it redirects these distant comets straight toward the inner solar system, straight toward us. Though Jupiter is not actively targeting Earth, its gravitational dynamics, however, constantly keep changing the paths of millions of space rocks. Sometimes it deflects a space rock that was headed for us. Other times, it catches a space rock that was going to miss us completely, but redirects it right into our orbital path, greatly increasing the chance of an impact. So, it is a completely chaotic numbers game, and Jupiter is the one rolling the dice. But to really understand why Jupiter is the most extreme planet, we have to rewind the clock 4.5 billion years ago. We need to look at how it built our world. Planetary scientists have a widely discussed model called the Grand Tack hypothesis, and if this model is right, the early solar system was an absolute war zone. Billions of years ago, Jupiter wasn't where it is today. It formed further out, but then it started migrating inward, closer and closer to the sun. As it moved, its gravity tossed asteroids out of the way, destroyed early planetary building blocks, and basically cleared out the inner solar system. This is actually why Mars is so incredibly small compared to Earth and Venus. Jupiter starved Mars of the materials it needed to grow. But then, something interesting happened. The ring planet Saturn finally formed and came into existence. Saturn's massive gravity grabbed onto Jupiter like a leash and stopped it from falling any closer to the sun. Then, the two giant planets locked into a gravitational dance and actually reversed direction. Saturn pulled Jupiter back out to where it sits today. This violent push and pull did something amazing. As Jupiter moved back out, it flung thousands of water-rich asteroids from the cold outer solar system directly into the dry, rocky zone where Earth was forming. Earth didn't just casually form with deep oceans. Our water was delivered to us by Jupiter's chaotic migration. It literally gave us the ingredients for life. Today, Jupiter's orbit is stable, but its gravity still dominates the solar system. Between Mars and Jupiter lies the asteroid belt, a region filled with millions of rocky fragments. Jupiter's powerful gravity constantly disturbs this region, preventing those rocks from ever forming a full planet and shaping the structure of the belt we see today. It also quietly stabilizes our home planet. Earth is influenced by the gravity of the Sun, Venus, Mars, and Saturn, but Jupiter acts as the great balancer. If Jupiter suddenly disappeared tomorrow, Earth wouldn't instantly fly into the Sun. The planet would freeze overnight and life would immediately end. But over millions of years, the delicate gravitational balance of the solar system would begin to change. Our path around the Sun would slowly stretch and change shape. The climate would shift in ways we couldn't survive. Jupiter is violent, chaotic, and terrifying. It creates dangers, and sometimes it removes them. But more importantly, it has helped shape the environment that allowed Earth to form and survive. Thanks for watching. If you found this video fascinating, subscribe for more genuine space documentaries, and check out the next video on your screen.